Hello everyone, in today's video I give a quick update on the Firebird drift build, repair the Subasharu steering, mount a roof rack to the Jeep, unbox the AMT 83 Camaro, make some progress on the 3D printed Skyline project, and install a new metal extruder motor mount on the Makergear M2. In the last video, I did a lot of work on the Firebird drift build. By the end, I had finished the installation of a bunch of new suspension and drivetrain components. After doing a little bit of driving to confirm that everything is functioning correctly, I wanted to test fit the body to see how well the suspension is aligned and positioned in relation to it. In order to make sure that the body was properly positioned, I needed to secure the front and rear bumper pieces, which I did using a little bit of tape. After the body was properly positioned to the chassis, I took a look at both sides of the vehicle to see how the wheels were aligned in relation to the wheel wells, and in the case of the rear wheels, to see if they evenly stuck out on each side. As you've probably noticed, the rear wheels are sticking out much further than the front wheels. I put larger hubs with several millimeters of spacing on the rear axle. I will be spacing out the front wheels some as well to give the car a wider stance. I also checked to see how well the fender flares look with the wheels spaced out this far. I think I'm going to move the rear tires in just a little bit, but I'm really digging the look of this wider stance. One minor thing that I noticed is that the left side wheel seems to be sticking out slightly further than the right wheel. This is not a problem though, since I can simply compensate for this by shortening the panhard bar. In addition to pushing the wheels in a bit, I'm also going to be lowering the rear and fitting some wider wheels with more back spacing as well, since I think the current ones look a bit too narrow, especially when they're spaced out like they are here. As for the front suspension, I think that the front wheels sit slightly too far back in the wheel wells, so I have adjusted the design of the lower control arms and printed them out. I also designed and printed some improved steering knuckles. I think I may also need to do a little bit of trimming in a few areas around the wheel wells, just so the wheels don't rub when turned sharply, but aside from that, the front suspension is looking and functioning great. I've also been doing a lot of brainstorming about what I want to do cosmetically to the car. Although I haven't completely decided on what I want to do yet, I'm definitely going to be going with more of a rough look. I plan on keeping the car in primer since I really like the way it's layered, and I may try to work a little bit of magic with an airbrush to give the car more of a weathered and grimy look. Maybe even throw in a few dents and some scrapes as well. I've got a pretty solid plan for what I want to do to the interior and how I want to go about designing the roll cage, so I plan on beginning work on that very soon. This week, I got around to fixing the Subasharu. I damaged the steering arm mount a couple of weeks ago before getting a chance to take it for a proper test drive. I went ahead and printed a new mount and installed it onto the chassis. Fortunately, this piece is super easy to access and to replace. I started by removing the dash, which is secured using magnets to get better access to the steering linkage. I then removed the two M3 fasteners that secure the steering arm mount to the chassis, and then secured the new mount into place. After crashing the car, I noticed that the steering servo was no longer functioning. However, after hooking up the battery and turning it on, the servo was now functioning just fine. Needless to say, I was pleased to see the servo functioning again. Hopefully, it continues to operate like nothing ever happened. If that's the case, this is definitely going to set a personal record for easiest servo fix. And finally, to secure the intercooler, I used some super glue. Unfortunately, I wasn't quite as lucky when it came to the weather on the day of filming, so I wasn't able to take the car out for a test drive, but I'm looking forward to getting this thing out, and I'll be sure to get some driving footage for a future video. I was also able to install the roof rack that I printed and painted for the Jeep Cherokee crawler a little while back. As I had mentioned in that previous video, I wanted to secure the roof rack using magnets rather than a more permanent method such as using screws or glue. The reason for this being that I want to be able to easily remove the roof rack so that I can easily mount my FPV camera to the roof of the truck when I want to do some FPV crawling. Originally, I was planning on ordering some rectangular magnets, however, I had some circular magnets on hand that were big enough, so I decided to use them. I held the roof rack in position and placed the magnets on the underside of the body. I was curious to see whether or not the magnets would have enough strength since the body is pretty thick and the magnets on the roof rack are relatively small. Fortunately, the magnets hold the roof rack on very securely, and I can't imagine any typical crawling or driving through brush being able to take the roof rack off. I adjusted it so that it was positioned how I wanted it, and then I used some tape to hold the magnets on the underside of the body in place. As I've mentioned before, I really like the look of this roof rack. It, along with the mirrors, side trim, and inner fenders, really helps give this otherwise relatively plain and ordinary looking polycarbonate body a much more custom scale look. With the spring weather finally arriving, I'm really looking forward to getting this thing out onto the trails. There are also a few other scale details I'd like to add to this truck as well, which as always I'll be showcasing in a future video. I recently had a chance to unbox this 1/25th scale AMT 1983 Chevrolet Camaro Z28 model kit. I know I've talked a little bit about this project on social media and in the most recent Fusion 360 speed modeling video, but to give a quick recap, I will be building this car in parallel with the second monogram Firebird I showcased in a previous video. Although this car will be using some of the same components I'm using for that build, this car will use an FDM 3D printed universal chassis rather than mounting all of the individual components to the chassis piece that is included with the model kit like I'm doing with the Firebird. As a result, this car won't be quite as scale in appearance as compared to the Firebird, but this car will be much easier to build and there won't be any concern about alignment when mounting the components. Right now I wanted to just do a quick unboxing and have a look at all of the parts included with this kit, take some measurements, and begin to figure out how I wanted to assemble this car and mount it to the chassis. All in all, it seems to be a decent kit as far as the molding and detail of all of the individual parts. After a bit of a closer inspection, I did notice a number of relatively minor defects, such as this hole in the dash. The main body piece looks great and is well molded. I will be designing some custom aftermarket style wheels for this car, though I also plan on modifying the stock wheels and tires so that they can be mounted to the car as well. It would have been cool if they included different colored stripes and emblems on the decal sheet for anyone who wanted to paint the body with a silver accent color rather than the gold, but I do like how they included duplicates of these smaller emblems in case you make a mistake when applying them. Since this car is 1/25th scale, there is a slight but noticeable size difference between it and the 1/24th scale Firebird. I'm looking forward to beginning to assemble and paint this car. I've decided to go with a black and gold paint job, which should look sick. Before painting the car though, I'm going to need to test fit the body onto the chassis to figure out what modifications need to be made. I think the only thing that I need to do is remove the inner fender sections on both sides under the hood, and I will definitely need to make some modifications to the interior tub as well, but I'll have more on that in a future video. So I've been able to make a fair amount of progress on the R34 Skyline project. This build features a completely 3D printed body and chassis, as well as several scratch-built styrene accessories. In the last video, I added some much needed details to the body and made a little bit of progress on the chassis as well. I decided that I wanted to start by redesigning the half shafts to allow for a bit more steering angle. Getting a sufficient amount of steering angle is a bit tricky due to the placement of the differential being further forward than the knuckle. This is done to allow more room for the steering linkage, but as a result, hinders the amount of steering angle. For more general racing, this steering angle is sufficient, but for drifting, having a larger amount of steering angle is ideal. I began working on a design in Fusion 360. I first figured out where I wanted the 1mm steel rod that the drive shaft will pivot around to be located, which I'm representing with these sketch lines. I then created a circle that will later be made into a sphere at the end of the drive shaft. I marked where I will want to make a cut into the sphere so that the shaft is able to not only rotate around the rod, but also be able to pivot up and down. After that, I sketched the outer section that will be a part of the wheel axle. Overall, I'm really just eyeballing the design and not really basing it off of any precise measurements. One thing I did change later on was that I made the angle of the cut I will be making into the sphere larger, which will allow the shaft to move more, and as a result, allow the wheels to turn sharper. After mirroring some of the features, I then began to use the revolve and extrude commands to begin creating the body. I used a create pipe command to create a cylinder along the path that I sketched earlier, which will represent the 1mm steel rod that I will be cutting and securing to the assembly. I then created a sphere using the initial sketch as a reference, and then made the cut into the center. I went ahead and beveled many of the edges just to improve the overall appearance of the part more than anything else. I moved these outer edges so that they are at a bit of an angle, so that the drive shaft would not collide with the surface and therefore allow a bit more movement. I used a Boolean command to create a hole that the metal shaft will be slid into. I increased the diameter of these holes just a little bit so that the fitment wouldn't be too snug, and then I made a flat surface around the hole on the top and bottom sides. With the joint section completed, I modeled the rest of the drive shaft. I printed out the shafts and tested the fitment. With all of the half shafts assembled, I began to install them onto the chassis. I started by attaching the steering links to the steering knuckles, and then glued the lower bushings into place. After applying a little bit of grease, I slid the knuckle and the half shaft into place. There still isn't a ton of steering angle, but hopefully this will be sufficient for the kind of driving that I want to do. I repeated the same steps to install the remaining half shafts and knuckles. I then placed the upper supports into position and secured them to the rest of the chassis. At this point, everything was looking and moving great. The only thing that I think I need to address is that there's quite a bit of play in the rear knuckles. I next began to assemble the steering components. After installing this upper steering arm, I noticed that the bottom of it was coming in contact with the screw head of the driveshaft socket. I will need to make some minor adjustments to the design in order to have enough clearance. I've also made a little bit of progress on the body, including printing out a new hood, which I plan on painting black. I was able to do a little bit of sanding to make sure that the fitment is correct and that the surface is prepped for paint. However, I haven't yet painted the hood. I have painted all of these styrene accessories that I will soon be mounting to the body. I received a lot of suggestions on what things you want to see me do to the body. A lot of people have suggested that I add some body lines, which I think would definitely add to the overall appearance. Adding the body lines is going to be a little bit tricky because a lot of the panel gaps are not well defined. I think that the best way to go about this will be to mask off the lines and then lightly airbrush them. This is going to be a bit tedious, but I think it would produce the best results. I had recently been having some issues with the extruder stepper motor on my Makergear M2 printer. While replacing this motor, I thought it would be a good opportunity to upgrade the motor mount from a standard 3D printed one to a metal mount that I got from the Makergear website. The mount includes all of the necessary hardware that's needed, and the instructions can be found on the Makergear website. An enclosure for the wires also needs to be printed. The entire process was very simple and straightforward. I started by unplugging all of the connectors and removing the fan assembly to gain access to the bolts that hold the filament drive. With the filament drive removed, you can see the cracks that have formed on the original extruder motor mount. When I did the V4 extruder upgrade, I noticed these cracks and applied a little bit of glue, but since then new cracks have formed. I loosened up the mount and slid the extruder motor out from the back. Next, I removed the old mount by unscrewing these 4 M3 bolts. I needed to remove the old front gear assembly from the old motor and transfer it to the new one. Before doing so, I made sure that all the gears were well lubricated and that they rotated smoothly. I next began to reassemble everything, starting with the new motor mount. I mounted the motor to the mount, as was indicated in the instructions. However, this updated wire enclosure needs to be installed before mounting the motor. With both the motor and enclosure secured, I reinstalled the filament drive and fans. It was a little bit tricky manipulating the wiring harness so that it would fit within the enclosure. With a little bit of work though, I got everything to fit. I used a zip tie to bundle up the wires and make sure that they were out of the way of the fans and hot end. And that is all there is to it. Not only is this new motor mount going to be a lot more solid, but I also really like the way it looks. And finally, I want to show some of the awesome pictures that have been showcased in the Make It RC Facebook group. And that is all for today's video. Thank you for watching, and I'll see you next time.